Hello everybody. In this video we're going to figure out all the resonance structures for oxygen, selenium, oxygen type compound. First thing we're going to do is write down the different types of atoms that we have because we need the Lewis dot structure. Oxygen, we are going to have a helium core, 2s2, 2p4, giving us a total of 4 plus 2, 6 valence electrons. For selenium, we're going to have an argon core, 4s2, 3d10, 4p4. Now this is a main group element, so we're going to ignore the 3d10s and just sum together the 2 and the 4 to give us 6 valence electrons. Now if we sum up our total bank, we have 2 oxygens giving us 6 electrons plus 1 selenium giving us 6 electrons for a total of 18 valence electrons in our bank. We need to place the less electronegative atom in the center. That's going to be selenium. We're going to put selenium in the center. We're going to bind an oxygen here. We're going to bind an oxygen here. We had 18 electrons to work with. We just made 2 bonds. Each of those 2 bonds required 2 electrons. We have 14 electrons remaining. We'll start by filling out the octet on our terminal atoms. I had 14 electrons. I just placed 12 electrons worth of dots, 6 and 6. I'm going to have 2 electrons left over to place onto selenium. Now, if we take a look at this, selenium does not have its octet. Oxygen does, but selenium has 1, 2, 3, 4, 5, 6. He needs somebody to share some electrons with him. And this is where we come up against a little conundrum that some students get a little confused about. Is this oxygen going to share with the selenium, or is this oxygen going to share with the selenium? They seem like completely equal choices because they are completely equal choices. And so our solution is that we're actually going to wind up doing both. We're going to have one of our resonance hybrids where we form that double bond with the right oxygen. And we're going to have our other resonance structure where we form that bond with this one. And we're going to predict that if we actually looked at this, we would see a bond order, a selenium-oxygen bond order of 1.5. We're never going to find a double bond or a single bond because it's really moving between these two forms very rapidly. If you want to condense this notation down, so each of these is called a resonance structure. We can make what we call the resonance hybrid. And the way that we do that is we indicate this bond flipping back and forth like this. And this time we're not going to draw out our dots because we really can't. We don't know. Sometimes it's going to have 4, sometimes it's going to have 6. But the lone pair on the selenium is always there, so we can always include that. So this could be our resonance hybrid.